So we may need that to trigger the recording. No, I'm joking. Oh wait, hang on.
Started.
Recording has started. Amazing.
Okay, fantastic. All right, well, maybe I'll share my screen and get started. If my screen is going to let me share it. There we go. All right. That should have done it.
Amazing.
All right, doing the recording. Cool, over to you.
Before we begin, we would like to begin by acknowledging and paying our respects to the traditional owners on the lands on which we meet today. I'd also like to extend a heartfelt respect and acknowledgement to the Wadawurrung people, who are the traditional owners here in Ballarat, where I'm broadcasting from today. Broadcasting, streaming, whichever. We would like to also pay our respects and acknowledgement to Indigenous elders past and present.
Amazing. Thank you, Developer Steve. And I'm on Kaurna land today in Adelaide. I'm usually here in Adelaide. So yeah, I acknowledge those lands too. Thank you. And for everywhere else you guys are joining in from today, whether if you're live or watching the recording later. All right, so welcome to the first lunchtime session for the Hack for Digital Healthcare with Telstra Health. We're really excited to be part of this hackathon today. Yeah, hello? Hello, Mark. Mark Yona. I'm just going to mute you if I can. Unless you have a question. So we are going to be doing a workshop today. I'm super excited about the whole theme of the Telstra Health Hackathon over the next couple of weeks, because they're really great problems that have come from real need in the community and solving great causes. So well done for being here and being part of it. Healthcare is definitely an industry where we have to really disrupt ourselves, but we also can't just move fast and break things like traditional tech companies. So it's really important to have these kind of hackathons where a huge variety of people can come together and solve some traditional problems in new and exciting ways. And so what that means is we can no longer have teams that are just like a team full of engineers and then a team full of doctors over here. We need hybrid teams with designers and patients and everyone to understand a bit of each other's world. And only then are we going to be able to get innovative and effective solutions that are actually solving the right problems. So that's the key. We're already here today. We've got some great problems to solve, so let's do them. And the workshop we're going to do today is going to be hopefully pretty simple. Anyone at home can replicate this for about $100 or so with actually no coding experience necessary, which is great. So the democratization of technology these days, so having things that are getting cheaper and cheaper, having things that are open source and free trials and low code software means you don't need a computer science degree anymore to experiment with Internet of Things projects. If you are a developer, if you are like a technology whiz, we hope that you actually get some new tools and skills from this as well. And we actually invite you to try this yourself at home and optimize the project for us, because Developer Steve and I have sort of just done the bare minimum here, but anyone out there that wants to have a go can really, really work on this to create something great. So the workshop we are actually doing is focusing on remote IoT alerts. So specifically, we're going to do something with these little Arduino devices here, which are wirelessly connected just with the battery, and to see if we can make an alert when they've made a rapid motion, so we can infer that they've fallen or something. But anyway, I'm Michelle and I'm from Telstra Developer. I'm here with Developer Steve from IBM, and we're going to take you here from start to finish. This is actually part 3 of a series that the two of us have done with API and IoT workshops. So you can check out my GitHub for the other 2 projects about how to get started with the Arduino and some environmental sensors. But this is sort of part 3. You don't need to have watched the others to get this though. Just a bit about me. I'm a developer advocate at Telstra Dev. And before that, I was in networks engineering at Telstra's 5G Innovation Centre on the Gold Coast. And a little bit more about me, I love all things emerging tech like virtual reality, AI, robotics, all sorts of crazy things. And I'm obsessed with South Korea as well. And I hope you guys get on the bandwagon. And I mean, we're here today with Telstra Health. When you think about Telstra, you don't necessarily think about, innovative healthcare solutions. And I don't think, you'd necessarily think about APIs and software as well, but here we both are. I'm from the developer center that actually takes Telstra's century of network leadership and unlocks it via APIs and IoT ingredients. So this is a place, our website here, dev.telstra.com, where developers can come, they can connect with the community with developer blogs, ask questions on our forums, get some access to the APIs, like the messaging API that we'll use today. And we also have IoT devices like the Arduino that we're using today, and sort of everything that you need to put a network solution together. And Developer Steve, did you want to tell us a bit about yourself as well?
No, not really. No, I'm just joking. I always wanted to say that when someone goes, tell us about yourself. No, hello, really excited to be here. Love, the idea of, I always love helping folks build out things that help people, because that's what my developer superpowers are for, in my opinion. So totally, looking forward to seeing some of the solutions build out over the event. Yeah, sorry, little about me. I sometimes go on tangents. Little about me. Where to begin? Fun fact, developer Steve Kuchin, for those that don't know me, hello. That is actually my legal name. So it's relatively new. Obviously was not born with that. No one really had the foresight to what I do now, which is a whole bunch of different things, including developing things. But got married a few years ago, and we combined our last names to create a whole new word. So Cooper plus Houchin became Kuchin. So that is my married name. I've also been an advocate and evangelist for PayPal, Braintree, for Xero, for Telstra. Good friends at Telstra. Previously, so just through doing a whole bunch of these events through Region, everyone kind of knew me as Developer Steve. So I thought, my name's in the shop, why not just upgrade it? So there you go. I guess a fun fact, I actually haven't used this one for a while. I don't know how well this is going to work, but I can hum and whistle at the same time. So there you go. That is a fun fact.
Are we going to get a demo of that today, maybe?
Maybe. I think I need some water, and I just suddenly on the spot decided to say that. So maybe then. We've got a bit to get through.
Awesome. And then about...
Oh, yeah. And so I'm here today from this company you may have heard of. So I'm one of the developer advocates here at IBM. Developer.ibm.com has a whole bunch of stuff. I always say, so from a developer and a technology enthusiast, and well, as a geek, I always say that there's over 166 toys in the toy box, and there is so many different products and so many different things you can integrate. One of my favorites, there's so many, but IoT things has always been a special favorite, including I have one of those, the boards that we're going to be using today in front of me as well. And this thing's kind of fun because you don't need any sort of special connectivity, literally a SIM card, and it connects into a whole bunch of coverage. So we're looking at that today. And then also Node-RED, which for those that haven't seen it, is no-code, low-code programming at its finest. So all drag and drop, connect up. You can still write code inside Node-RED as well, but we're going to take a look at that today. So I'm really excited to, just share that and geek out and see what amazing things come out.
Absolutely. And there's going to be some amazing things, hopefully. So enough about us, enough about all that stuff. Let's get on with today's workshop. Thank you, Developer Steve, for introducing yourself as well. We're going to hear you humming and whistling later. Maybe that's a special after the recording, maybe for people that want to
do it after the recording. Then I can have a drink of water.
So I'm just going to keep moving by introducing these first two terms there, APIs and IoT, just in case you haven't heard of them before, or maybe you have heard of them and want to learn a little bit more. And then we'll go straight into the fall detection demo. So APIs, it stands for Application Programming Interface. And so it's pretty much when two software solutions can communicate with each other. That's it. It's connecting two things without the human in the middle, I guess. And APIs are actually powering pretty much everything. And I guess the point of them and the four main reasons why you would use them is to access data securely, to extend the functionality of your app, and to abstract complexity. So the abstracting complexity bit is really important. So APIs kind of take care of all the stuff going on in the background so that you can just interact with an API on the front end. So we're going to show you the example of the Telstra Dev messaging API, how to do that. So I guess the example here is you wouldn't want to build an entire mobile network with SMS functionality if your app is about delivering food, right? You want to focus on your core business, on making food and delivering it. And if you want to send a text to let someone know it's being delivered, then that's when you would use an SMS API. You wouldn't want to build a whole network for yourself. And that's sort of one example for APIs. I guess another analogy that I've heard used a lot before is an API is kind of like a menu. So you have that menu in front of you. You can see everything that you can do, everything you can order. all you need to know is how to select your favorite item and then how to eat it. You don't need to know what the chef is doing in the background. You don't need to know the recipe or where on the shelf each of the ingredients are. So the API just becomes that menu there. Enough about APIs for now. If you have any more questions, you can ask us in the chat or ask us later. The next three-letter acronym that I'll debunk today is Internet of Things. So IoT is the billions of physical devices connected to the internet. And IoT, there's actually already more IoT devices in the world than there are people, which is really causing like a tsunami of data going through the network. And that's where things like artificial intelligence, cloud computing, edge computing, those sort of technologies become really important when there's so much data going to and from sensors all over the place, right? So the three key elements of the Internet of Things, the first ones are those devices that collect the data. So devices like this little Arduino here with some sensors. This is a really key part, that you have some sort of sensor somewhere that's collecting data. The next part is the connectivity, so the network that lets you send the data somewhere. And the third part is the application, so something on the end that actually makes sense of that data. So you wouldn't just be capturing data for the sake of it. You might want to be analyzing it, displaying it, and acting on it somewhere. So I'm going to focus on the middle bit now, the network. There's lots of ways you can connect a device to the internet to make it an IoT device. Some networks like Wi-Fi and Bluetooth are kind of cheap and easy to use in the home if you're just getting started. If you're outside or you're doing like non-critical activities, you might have some other like LoRaWAN coverage that might be out there. But for some more critical projects where you really need reliable connectivity and greater coverage, we're talking here about Telstra. So Telstra has 4 million square kilometres of cellular IoT coverage across Australia. That's quite a bit. And it makes use of our 4G and soon to be 5G network as well. We call them low power wide area networks, and they can go up to 120 kilometres to the device. So the device could be 120 k's from the tower, which is pretty crazy, which is great for like rural and regional areas, of course, when you might not have reliable 4G or 5G coverage. But it's also good in rural and urban areas. So think about this kind of device. If you wanted to put this like underground, under the roads in the Melbourne CBD to do like parking sensing, for example, you wouldn't want to have to dig that up and put construction on the roads every day to recharge the battery, right? So you want something that has much longer battery life, that can go underground and still get coverage without having wires and things like that. And that's where this sort of remote monitoring comes into place. So the whole use case for this device connected to the Telstra Cat-M1 network is that all these things will be a lot easier. And of course, from a developer perspective, having firmware updates over the air, being able to get your data remotely without having to like take a USB stick out to your device and download all the sensor data, it makes it, I guess, much more convenient. And the last thing is this network has inbuilt security on it, so you don't have to waste like overheads coding in different security features. It's kind of inbuilt into the network.
Can I just add two things to that last slide? Thank you. Just to reiterate 2 points on there. One is friends don't let IoT friends not have over-the-air updates. Please build in over-the-air updates, because you do not want to visit 10,000 devices in the field, just saying. Or maybe you do. It's going to be a lot of field work. I feel there's a pun here, but I'm going to keep going. The other one is just keep in mind these amazing networks have a wide range of coverage, but low bandwidth, hence the low powered part of this. So for instance, you cannot do video calls over either network, Cat-M1 or narrowband. Just keep that in mind. For these devices, it's absolutely perfect because you're just sending small JSON packets backwards and forwards. Like it's very, very low bandwidth. So just two things to keep in mind. Over-the-air updates, very important.
Over-the-air updates is important, especially when you're doing these things at scale. So like with us just having one device at home for this prototype, it's fine. But if you actually sent this out to potentially patients all across Australia, you wouldn't want them to be like having to plug in and update their firmware, every time you do an update. So yeah, for sure. And yeah, that low power thing is important. So the kind of data that we're going to be sending from this device today, I'll show it again. The kind of data we'll be sending is literally like, a JSON string, just a few like bits of information, really. We're just sending the environmental data and the XYZ parameters of the acceleration on this device. So yeah, low data rates is key. And I guess that's the trade-off. Like that's where 5G will come in, where you need really high bandwidth, you need a lot of data rate, you need low latency, all these things, and you're willing to trade off like the coverage. So neither 4G nor 5G has this kind of coverage, and that's because the way that the network is built. So it's great. So we're actually going to be doing a demo today that is an example of environmental monitoring. So taking information from the environment, whether that's temperature, humidity, like we've got location, acceleration, all these kind of things, and measuring it. So the point here is that we measure what matters, right? This device, and we're not taking every single thing possible from the device. We're just taking what matters. And that's where you sort of can get data from your things to make insights and make them more efficient, make them safer, and then potentially automate some things by having that data, right? So an example I'll give, here's one here. In a smart city, you can have a little sensor in the bin that measures how full the bin is. And a couple of cities, including Adelaide, do this already, so that they have a sort of data, they have a map of all the bins in the city area, and you only need to send someone to collect a bin that's full. You don't go to collect a bin that's empty. So that saves time, saves resources, and potentially can keep the city cleaner by actually going and collecting bins that are full before they start spilling over. Energy, in your house, for example, I know you've probably heard of like smart lights that only turn on when someone's in the room. So that's one example. But imagine that like on a city level. So imagine, the lights in your home, yeah, you can save, tens of bucks on your electricity bill and it's better for the environment. But imagine if on a city scale, is someone else on mute? I'm going to mute that person. Oh, good. Not on mute, they put us on hold. That's all right, we fixed it. So yeah, and think about the scale of this connectivity. So that's where you can be more efficient. I won't need to say much more than that. All right, today's demo. So what we're going to try and do, I'll just give you guys an example. We've got our little Arduino device with an IMU sensor on the top. So this measures acceleration in Gs and a couple of other things. Maybe, what else does it measure, developer Steve, this IMU thing?
It was magnetometer. Oh, I seriously need another coffee today. Magnetic-ism, let's go with that.
Sure.
Such a professional. Accelerometer, and there's a gyroscope.
Yeah. Okay. We've also, because these Arduino devices, the MKR NB1500 that I've got here, it's got the Telstra CAD M1 sim in it. It's also got an environmental shield on top of it too. So you can see I've got 3 shields actually stacked. You probably can't see, but anyway, take my word for it. And the shield in the middle has got temperature, humidity, UV, and light reader on it as well. So the idea is that this device, if you could get it down to a smaller form factor, you could potentially wear it, someone could wear it, or you could put it on a device that is fragile. And then when the device actually falls, when it drops, it'll have an increase in acceleration. So we measure that in Gs. So the XYZ coordinates of the accelerometer is in Gs. And when it drops, we should be able to receive a text on our mobile phones to alert us that the device has dropped. And so we've actually configured it so that developer Steve and I both have the identical devices on us on each end. We've also both got it set up to text each other. So if developer Steve's device drops or falls, I'll get a text. And same thing if my thing drops, he'll get a text, and vice versa.
Which was funny for testing, because last night we kept sending each other text messages by testing the devices, so we know they work. Also,
I was just playing around with it, and you must have got like bombarded with spam text.
With text message, I was doing the same. This is fine. Also, in case you're wondering, G stands for OG when it drops really quick. No, G is gravity.
Oh gosh, that's what it stands for. Oh geez. So I guess a disclaimer here. We sort of put this together. Like I said, the point of this prototype is that it was quick, it was simple, but we're using cheap and free software. So it's not a completely full working prototype. Developer Steve managed to find some open source code around the place that did things like measure the rolling average of the acceleration. We were doing like some small physics. I reckon we were doing some physics in there. It wasn't too bad. Luckily, you don't have to do that because we've done that. But this is not a full working prototype. Like you wouldn't attach this to someone and expect it to be really reliable, because one of the things is, anyway, we'll show you later, but this is a great proof of concept. It works.
Is that just me, or did everyone freeze?
Nope, Michelle froze.
Okay, cool. I was thinking, oh, my system froze. All right, I'm going to pick up where Michelle left off and hope that she comes back in a sec. Just to reiterate, yeah, these are prototyping boards. So these little Arduino devices are great for hooking up to test a concept, test a theory. But this is not stuff that you would ideally take into production, only because there's potentially a whole bunch of stuff on there you're not going to need. So, and these shields, great testament of that. You're not going to need a lot of the sensors on there because the thing you're going to build out will have very particular needs. And at scale, this IoT stuff, you can refine the boards down and bring the cost down even more by having the things you don't need on that particular device. Oh yeah, Michelle's definitely has timed out. Okay, that's fine. Michelle will be back soon. Oh, I think she's back.
That was so weird. All right.
Yeah, I know, because I thought, is that
Did
me?
you also drop out, or was it
Michelle
just me?
freeze? No, it was you. Someone jumped in and said, no, she's definitely frozen. And I was like, cool, thanks.
My gosh. All right. Great. Where did I lose you?
I was just talking about these being, continuing your line of thinking around the device being prototype only. And then I was kind of talking through how you want to refine, use this as a prototype on, then refine your design down a bit to prototype just what you need to keep costs lower, etc.
Fantastic. Well, I might pick up from here then, which is sort of like how we're actually going to do it.
Yeah.
Right. So the first thing I'll just mention is I already put a link in the Teams chat here, but we've put up the code for this demo up on GitHub already. So if you just type in GitHub Michelle Howie, you should find me, Little Jack Sparrow. And this is the Arduino MKR IMU fall detect. So up there, you'll find our Arduino sketch. You'll find the JSON that you can import into Node-RED, so you don't actually have to do any of the work here. Which means I think it's great because we've open sourced all of this. It's really important that you can just take this yourself and then start building upon it. You'll just have to add in, you have to register on Telstra Dev to get your client IDs from there. You have to register for IBM Cloud and on Node-RED and the Watson IoT broker so that you can put in your own credentials. Other than that, we've got everything there for you. The hardware that we've got, I've already mentioned, the Arduino MKR NB1500 board. We're using the IMU sensor shield today. We also have the environmental sensor shield, which is not part of today's demo, but it's still really cool to use. And you'll also need a SIM card for the Cat-M1 IoT network. If you grab any of the other Arduino boards, they might be Wi-Fi. You could probably use another kind of board too, but that's just what we're going with today because that's the easiest thing for us to get started. And Telstra Dev actually has these Arduino boards and the SIMs on our website too, so you can find those if you need them.
Just going to jump in quickly. You totally can use ESP32 with Wi-Fi. One of the reasons why we like these ones though is particularly with user-based deployments is don't need to set up Wi-Fi like you do with, I've got some LiftX lights, for example. I need to pair them with the app, then get the app to get them to connect to the actual internet, whereas these things are all literally power and they connect. Yeah, but either will work. That's why we're using these ones today, and they're kind of cool and fun.
Yeah, plug and play is the best thing. And like I'm in a pretty big house here in Adelaide, and sometimes like I put these in the greenhouse sometimes, so they do like humidity and temperature in my greenhouse, and I don't get Wi-Fi all the way out in the end of the garden, so that's like I have to use Cat-M1. I can't use anything else at the moment. Yeah, so that's that. I'll just go through, I mean, we talked about it quite a bit, but this is just sort of, don't mind my drawings. This is like the end-to-end flow of what's going to happen. So we've got our Arduinos with the sensors connected to the Cat-M1 network. When they have high acceleration, past a certain threshold, it's going to send that acceleration, the XYZ coordinates, to the Watson IoT broker. So the device connects to the IoT broker, and that kind of handles all the messages to and from the device. It's really handy, and maybe developer Steve, when you open up the IBM stuff later, you can talk a little bit more about how the broker works. But very simply, it takes the messages in and out from the device. It then sends it these events when they occur to the Node-RED endpoint that we've set up. So we've got a couple of different endpoints and webhooks in this demo to make everything work, which we'll explain later. But pretty much in Node-RED, it's where the information is sort of made sense of and passed into different things. So we send the acceleration when it's reached a threshold. We then have to enter that into a text message, find who the text message is going to, and then send it out to the Telstra Dev messaging API gateway. So after Node-RED decides that we need to send a text, it gets sent to the Telstra Dev messaging API gateway, and then gets sent back to as a message fall detected to the person that we've set up. And in this case, it's myself and developer Steve, and you might be on the 4G network in Ballarat, and I'm on the 5G network, 4G or 5G network here in Adelaide. So that's pretty much the loop. Hope that makes sense. What I'm going to do now is just quickly show how to get started with the messaging API really quickly. And then I'll hand over to developer Steve to show the Arduino and Node-RED instances. So,
just while you're setting that up, I'm just going to say your hand-drawn diagrams are brilliant. I love those. Just saying, they're so much more nicer than the usual drawn, the drag and drop ones. But anyway, just wanted to throw that in, and I know I can hear people agreeing. So there we go.
I can hear you nodding your head. Someone has their hand up.
I did see that too, but I didn't know where to do something with that.
I can't see who it is. So if your hand's up, are you able to go off mute, or maybe they're not allowed to, or not able to?
I feel that's a Luke question, because Luke is the most amazing team support person ever. I am just going to say that now.
Thanks, but I don't think they're muted.
It might be, anyway, that's fine. If you have a question, I want to hear it. So maybe at the end, or post in the chat, or somehow we'll get to your question, because I want to hear your question. Cool. So we're about halfway through the time now, which is great. Great job. We've got all the background set up, and now we're going to actually go into how you can execute this. So I'm just on dev.telstra.com. So that's Telstra's developer portal. I've signed in with my free trial account. So anyone can just log on here, create a free trial. Off you go. Nothing else needed. If you have any questions while you're going, we have our forum here where you can post any questions about the messaging API, and myself or someone else in Telstra Dev will check it out. Also, you can find us on Twitter and on GitHub, where you'll have the SDKs that you need to get started with this API. All right, so first things first, I'm going to go into our API registry. And here's the list of the APIs that we have available at the moment. So I'm just going to go straight into the messaging API, which is what we're using today. And as we mentioned before, this you don't have to be like a computer science whiz to be able to use these APIs. There's actually some code samples. Well, we have a whole repo in GitHub as an SDK for this API, but we also have some code examples that will be really easy for you to get started. So pretty simply, this API is to send and receive SMS and MMS globally. Pretty easy. A couple of features, so you can send to multiple people at once. You can use an alphanumeric identifier if you're on the paid account. So that means it can come from, what's an example? It can come from
a name.
Michelle.
Yeah, you can have it come from an amazing e-commerce store, or mowing store. Just it adds a nice personal touch.
Michelle's mowing instead of from +61 blah blah blah. So that's really good. That you can check out. So as I said, you can log in for free and get the free trial, and this just explains what that includes and what it doesn't. But that's pretty much it. I'm going to go straight to getting started. So it's three pretty easy steps. The first thing you need to do to use the API is generate an OAuth token. So for that, you're going to need your client secret and client ID. So to get that, you're going to go up here. So I've logged in, remember. Under develop, there's my apps and keys. And number one rule is don't share your keys and your secret with anyone else. So I hope this doesn't come up and show on the screen here. Nope, perfect. So you'll get to this page, my apps and keys. If you click that drop down, you'll be able to see your client secret and client ID. I'm not going to do that today, but I've already got those and copied them and put them into Node-RED. So you're going to need these later. Take note of those. And that will generate your OAuth token to make sure that you're authenticated to use this API. Then you're going to provision your virtual mobile number. So when you use the API, you can send and receive messages from a dedicated Australian mobile number, which is pretty cool. And we're going to provision that number in Node-RED, actually. You could also do that in Postman first if you wanted to do that. And we have Postman's a great tool for testing APIs and doing things like that. So you can run that in Postman. And when we create that subscription, we're going to receive the dedicated number that we're going to be able to send that text alert from. This number is also actually used in part 2 of this demo that developer Steve and I did earlier in the year, where you could actually text this number and ask it for the temperature reading. So like I said, on this Arduino device, on the Arduino board here, we've got the environmental shield also connected in the middle. So you can actually send a text to our virtual mobile number and it will respond to you with what the temperature is of that device, which is great. A couple of things we need to do when provisioning that number, but we're going to do that in Node-RED later. And then the last thing you do is send a message. So pretty easy. The only other thing that I'll mention is if you are on the free trial, there's something that you have to do in between that. So after you've provisioned your number, you need to actually register a list of recipients who can actually receive text from you. So in the free trial, you can only send to up to 5 Australian mobile numbers. So you need to actually declare those before you can send your first message. We make that pretty easy here because there's some code samples here that you can try. I'm actually adding in some different languages like Python, Node, whatever that you could use this for. But here, for example, this is the body that you need to send in that call. So we're going to actually do that as well in Node-RED. So like I said, you don't actually need to write any code with this. All you need to do is replace these numbers with yours, copy this text and paste it in the right place in Node-RED. Pretty easy. Last thing I might mention is with the provisioning, to create a subscription, there's one parameter that we're going to need to add when we're actually calling this create subscription API call, and that is a notify URL. The notify URL is actually declaring the place in the cloud, in the internet, where your messages are going to be sent and collected and sent somewhere else. So here, our notify URL endpoint is going to be within Node-RED. So that any text that's sent to this mobile number is going to end up in Node-RED, and then we can actually pass that message somewhere. So that is all I'll need to say. Oh, on the free trial, these numbers are active for 30 days. So you can keep provisioning it after that, but each of them is only active for 30 days. And I guess maybe the last thing, I said the last thing a few times, but this is the last thing. When you're sending an SMS, the things that you need in the body of the API call, you need, of course, to. So who you're sending the number to. In Node-RED, we're going to predefine them as Steve and my numbers so that we actually get the text to us. So you would obviously put your number in this place, in the to place, after you've registered it as a B number. The body is also going to be predefined by Node-RED. So it's going to add in, if you've texted in to ask for the temperature, Node-RED is going to say, right, I'm going to send you back the current temperature, bring in the current temperature from the IoT broker, add that into the message body and send it. For this case, it's going to have a predefined message, your device has fallen. So it's pretty easy. And now that's it.
Wait, just one more thing. No, that's the
last thing.
One more thing.
Okay,
I actually had nothing. I just wanted to say that.
Oh, good. There's plenty more things I could talk about, but I'm going to stop myself here because the most exciting part is the Node-RED. But I'm going to hand over to developer Steve to talk about this and also maybe the Arduino sketch as well. So while you're getting ready, I'm going to stop sharing in a second. But the last thing is to remind everyone that here in GitHub under Michelle Howley, Arduino MKR, IMU4 Detect, developer Steve and I have written up a pretty good README to explain exactly what we're going through today, all the things that you need to get and where you can get them. It's got the actual Arduino code here that we're going to go through in a second. Easy. Obviously, there's lots of insert yours here because we haven't put our client IDs in there. I was worried that I had for a second, but no, we're good. That's the only thing you need to do is add in your own client keys. So I'm going to stop sharing. Your screen is a little bit blurry, developer Steve. I don't know if it's just
Is it?
Me. Yeah.
Wait, you can see. Wait, can everyone see my screen when I start talking? It might even be a click my video thing, maybe. I don't know. No?
I can't even read the text that's on the nodes.
All right, let me do some screen sharing things. I'm just going to move a few of my windows around here. See, this kind of sums up like 2020, right? Like being agile. Being agile.
No, we're not worried. Okay, while you're doing that, there's a couple of questions in the chat.
There we go.
All right. What will the user be wearing from Vanessa? I assume you mean if you're trying to detect the fall from someone, what would they be wearing? So in this example, like we said, this is a pretty hacked together prototype. So this device is quite big with the battery pack. I just didn't mention that this is actually a battery pack that I've got attached to this. Other than that, it's wireless. I don't know. I think that's up to you guys. I think you could put it in a backpack. You could put it on a bum bag. You can put it in the pocket.
You could actually get this small enough to build into a watch or an armband as well. Like you can, or even a pendant. I know Misfit Wearables, for example, they have it's actually really cool. It clips out and can go into a watch or a necklace. Does something very similar where it's like monitoring health related things. That uses Bluetooth. No, that's a Bluetooth device. This is, yeah, actual Cat M1. So the reach is a bit better. Also, you don't need a phone to connect it to. But yeah, like Michelle was saying, this is prototype. So it's more the concept of, but as for what you do with the product side of the wearable, totally up to you.
Good question there, Vanessa. There's a couple more questions that I might just call out now, even if we don't answer them. The next one is from Evgeny, which is, how often is data pulled and what is the size of the data pool? So that's quite interesting. I think you'll answer that when we go through it.
I will. I'm going to talk about Mqtt, one of my favorite topics. We'll get into that.
Amazing. Chilu is who had their hand up. So Chilu, I'm sorry we can't hear you. So if you just post in the chat your question, we'll look at it in a second. And that's it for now. So go ahead, Developer Steve, and take us through it.
Oh, I got muted. Oh, wait. Can you still hear me?
Yeah, I can hear you. I can hear you.
Yeah, cool. All right, cool. So hopefully everyone can see my screen now. This is Node-RED. And like I was saying, it's all drag and drop. And the stuff that Michelle just walked through with the API connecting into Telstra Dev, there's an entire flow that does all that for you. It's kind of fun. You are potentially going to see my key, but that is fine. Well, just don't write it down. But you can go get your own. They're free. So Node-RED's really easy to use. Generally, so all your nodes or your program, these are like little program snippets basically, and they're already built for you. And as you can see here, they connect up to a whole bunch of different services. So speech to text, you can connect it to Watson chatbot things. Like there's so many different things you can connect it to. And you can actually, there's a whole community of people that have released under, it's all open source. So they can kind of build their own nodes out and share them with the community. So this is only some of the nodes, only the ones I needed. You can look through the different community ones and add any of your own, or even build your own, which is kind of cool. So you can even do CSV, HTML, you can build dashboards, so cool. Just to give you an idea of what it looks like, this is one really basic flow here. So there's a inject node. So this kind of creates your ongoing loop, or at least your one-off loop initiation. So with OOP programming or object-orientated programming, such a tongue twister. Yeah, you need something to sort of initiate that section of code or that section of the flow to start working. And this does that. It could also be just an SMS coming into an endpoint, which is basically what we've got set up in one of these tabs. But yeah, you need something to start it or to trigger that program or that bit of code to run. From there, and you can see here, it's got that little connecting line, which is pretty cool. You can do multiple connecting lines as well. So if I drag another debug, which does like an output of variables, I can connect another one up there if I wanted to. I could even switch them off. Wait, that wasn't switching. Oh, it would help if I deployed it first. I can also switch those off as well. So if I click disabled on there, it'll go dotted line. So it can just sit there and not run. And then this is probably one of the most commonly used nodes as well. And we're going to use this one a little bit today, is the function node. So you can write straight JavaScript inside one of or a node inside one of these function boxes as well, if you needed to reshape data or handle data in a certain way. So this is where you can get a little bit more tricky. You can also move variables around inside the transports, but we'll look at that as we go through. And then this last one, another really commonly used node is an output debug node. So the variables that get passed through this flow, you can output to a wonderful little debug box, which you can see there. I'm just going to switch that to current flow. That way I only see the messages that come into the flow that I'm on. So yeah, you can see here, I just changed the output to complete message object. So anything that this flow generates will automatically output at that part of the flow. That's kind of Node-RED. It's really easy. The account that I'm running this on is a free tier account on IBM Cloud. So if you set up a free tier account, go into the IBM catalog, search for Node-RED, there's a self-deploying script that's pretty much ready to go. That is exactly what this is. I just set this up on the free tier. One thing I really like about Node-RED for hackathons is prototyping, because you can build out anything you need right through from even APIs. Like you can build your own APIs inside this. Yeah, to get yourself up and running. We've got on developer.ibm.com, we even have code samples that help you build chatbots and do all sorts of machine learning stuff all through Node-RED, because it connects to pretty much most of the toy box. Just to start going through some of the stuff, this is sort of looking back to the Telstra Dev API calls. We've got all the flows you need to get you up and running. So once you've got your keys, this is the provision virtual mobile. So this gets you your initial mobile number with a endpoint. So the endpoint in this is really important with the Telstra Dev API, because when someone messages back in, that's the URL that message will get sent to. And we'll look at that. Actually, let's look at it now. So this is our flow that's actually requesting humidity and temperature sensor data right now. As you can see there, that's actually pulling it in from one of the devices. Yeah, that's the one, literally the one sitting right next to me. So to answer that earlier question, how often is the data triggered? With the sketch that we've got for the demo that we've got today, the server's actually requesting data from the device. So you can see this flow up here. This Inject node is running for the first 5 seconds, and then every 30 seconds, it's sending a message into the IoT broker, which is this connection here. So on this free tier account, I'm also running a free version of What's an IoT, which is our IoT broker. And I'll go through more on the broker side in a second, but it's basically injecting a message in, and the message is on. It didn't have to be anything elaborate. It was literally just on. So the device is connected to the same broker. It's listening into the same category, which is trig. And so when the Node-RED instance puts the word on into the category on the broker called trig, the device sees that, picks it up, grabs all the details from the environmental shield, builds it into a JSON string, and then sends it back into the broker on a different category. So, or topic, sorry. Keep saying category. It's actually topic. So that's exactly what this is listening for when the device puts that into the topic known as sensor on the broker. This is listening on the other side of that then, and then picking that up and then outputting it here and storing it in global variables. You could just as easily store this in a database, but we were keen to not have too many working parts. But there's a whole bunch of nodes and ways to connect it up to database and do long-term storage things. We're literally just storing it so that an SMS, it can respond back to an SMS request to get more information on environmental conditions, which is pretty much what's happening here. Just a little bit more on the IoT broker. So we're using What's an IoT in this. It's built on industry standard protocol known as Mqtt. Mqtt is essentially what your internet browser does, just stripped down a whole bunch. So when you go to a website, your browser picks up a whole bunch of header information that you won't see in the browser. Like the browser basically knows a whole swathe of info about the server and about the page it's being handled, being sent, etc. These little devices not only don't want to know about all that stuff, like it's in most cases they don't have much memory and much resources anyway. So it actually doesn't want any of that sort of stuff. Mqtt fixes that because it's it's an extremely low header protocol. So it's got a really tiny low header, and all it's really interested in is the body text. So a JSON string, for example, or a text string or something extremely light. That's the difference. And yeah, this is What's an IoT. I've already got got it set up here. You can see here there's 2 devices registered. They're really easy to set up and get them connected to. We've already got the Arduino sketch. All you've got to do is drop in some details. But yeah, you can see here there's Michelle's just connected. That's my device there. And then Michelle's is the MKR1, MKR, the bottom one. And mine's the MKR2. So you can see here they're already connected. We've also got 2 apps, so we've actually got a few apps. This was us testing yesterday. We've also got a backend application keys set up inside Node-RED, which you can see in here. That's all this What's an IoT drop-down stuff here. That basically tells Node-RED how to connect into the broker, and then you just set the variables of what you're actually listening for. So which board type, which board device ID. In this case, I've got all of them ticked. And then also the sensor, so what it's actually listening to as a topic on the broker. So the broker, think of it like actually think of it like Reddit. So on Reddit, you have all these different like sort of subthreads and stuff, all these different topics. It's kind of similar to that. You're essentially putting a message in at a particular topic type so that only things interested in that topic can subscribe and listen to. It's kind of the basics of it. So to go back to this, back to provisioning a number on the Telstra Dev API, like we said, like we've already got the flow sorted for you. These are, and this is all on that GitHub repo, so you can import that as a JSON file, and all this will import in. You can just delete what you don't need or update what you do. So we've got these turned off at the moment. You turn those on down here. It's got disabled. You can just switch that on to enabled. This trigger is only set to run once you click deploy. So this little deploy button here deploys any changes you do to your Node-RED flow. So you got to make your changes first, hit deploy, and then things will run. Not going to keep this screen open for long. My creds are in there, but essentially this sets all the header information for the API call. In the one on the GitHub repo, it has a section for you to update with the token, the secret and key that you get from the Telstra Dev portal. This then executes that request. So this is literally doing a straight up API call to generate a token to then do a particular thing. In this case, provision the number. This just converts it to JSON. It's rather unexciting. So the response it gets back is an object, is JSON, and then this converts it into an object so that you can then use that token to then make an API call. Really important when you're provisioning a number is this notify URL here, because this is where an SMS coming in will get picked up by the system and then handled. So I'll show you back on the tab we were just on where you set that, but this part here has to be updated, and then also your Node-RED deployment URL also needs to get changed as well. So that's just the one I'm using here. Then again, just does the API call to basically update the provision details, and then this is just an output to show that it worked. And it's literally the same thing with adding B numbers. So these are authorized numbers that this will respond to, send to, get SMS from, for example, except you just update your mobile numbers in that array right there. And then same thing, you just enable, not disable, enable this node here, and it will run one time once you hit deploy, and then just disable it again, and it's good to go.
Can I just jump in quickly on that one? So if you go back to the provision and B number section, the really cool thing here that we've done, especially by open sourcing this project for you guys, is that you can actually just copy these nodes and do the same thing in your demo. So even if you're doing a completely different demo to us that might be doing an alert or something else, you can reuse these nodes to be able to send an SMS on demand, like provision your mobile number and stuff like that. So this is pretty handy.
Yeah, totally. Yeah, and it just helps get started. But totally feel free to hack this up and do all the amazing things with it.
Yeah, and also we had a question in the chat I'll just quickly bring up too. So Wei Ying said, is the environmental sensor the same as the sensor that we're using for the fall detection? So we're using two sensors actually. So the cool thing about Node-RED and all this is that all these nodes can just be reused really easily. And our NKR boards, the sensors actually just stack up on top of each other. So we're using two different sensor shields on the same board. The environmental one that developer Steve was just going through, and the one that's coming up on the debug screen, that was used in a previous demo that we did, but it's still kind of relevant here. Whereas the IMU sensor, which is the one that does acceleration and gyroscopes and stuff like that, is the one that's going to be specifically used for fall detect. But this one Node-RED instance actually does both at the same time. So that's the answer. No, it's not the same, but they both use.
We like to live extremely dangerously by doing 2 demos at once.
Yeah, and there was a new question from Evgeny. Yeah, that's very dangerous, but it's working, so touch wood. Another question just came in from Evgeny, which is, how is subscriber identified? Is it one-to-one or one-to-many for each device? So the subscription that we provision in this Node-RED flow sort of like runs the whole demo. So that virtual mobile number is the one that sends and receives messages out. So it's one subscription that is sending out text to, so anyone that messages in and asks for the temperature reading, that's using the same mobile subscription as the one that's going to send us a text for the alert. And also, I didn't mention that the free trial only has 100 messages in it. So if you are using this demo, try not to shake your device around too much and send 100 texts, because then you'll run out of the free trial.
Just to add to that subscription thing too, on the What's an IoT broker subscription, that's a one-to-one for devices as well. Otherwise, it does. I've done that before. It does not like it. So one of these entries is one device. It's kind of easy to manage. This actually does also manage over-the-air updates as well. Yes. But yes, this is two separate demos that, well, we just thought we'd leave the other one in there so you can see what it's doing. So this is the endpoint here. You can set these up as you need. You can actually set them up to build web pages in as well, which is also kind of fun. But yeah, the /AH is relative to the URL at the top. So it's just the base URL followed by /AH will get you a endpoint. And this is just doing a post request. One thing we discovered yesterday is make sure you're sending back a HTTP response, just so when the webhook sends a message in, it knows that it got it. It's like saying, hey, yeah, I got the message, thanks. I did call it everything's fine. I thought that was an app name. And status code 200 for HTTP buffs is everything's fine. Then so this is getting a message in. Once we get a message in, and I know I could have written this a whole bunch better. I just wanted to make it nice and easy for folks to be able to see what I'm doing here. And I know doing a whole bunch of nested if else's is not necessarily the best way, but just thought I'd throw that. I would normally do it through regex, but regex, but yeah, literally all it's doing is when someone messages in temp or pressure or whatever else, what they're requesting for, it's able to match that. And of course, always make sure you're doing a lowercase drop on all your incoming variables, just to make sure it's a little bit clean, and always sanitize. I'm not doing it here, but you should sanitize. I don't think I needed to, but yeah, I mean, famous last words, right? But yeah, once it does a match, it grabs the detail being asked for, or if it cannot match anything, it just goes back with a help menu response text that says, hey, here's the things you can ask for. So the drop part of this is very similar, except that we're not needing to request data from it. We need the device to actually send us a whole bunch of stuff. So when the device threshold, I'm going to switch to Arduino, the sketch code in a minute, and talk through that, because this side's really easy. This was actually, I want to say this was the easiest bit of this entire process. It was actually the trickiest, just because getting the data in the right format from the device into the broker seemingly was tricky late on a Friday afternoon, Murphy's Law in development. But yeah, literally it's the same as what we've just walked through, except we're watching a topic called fall on the broker, which the device, when triggered, will put a message into that queue. And then all that this has to do here is prep the to for who the SMSs will go to, as you can see there, and it's just sending the body of a device that's had a fall. There is a missing element to this entire flow. Just a side note, I'm going to throw this in. If anyone can tell me what missing element is, and I know what it is, just because I've realized today maybe that there is a slight missing element to this entire flow. I have a whole bunch of Deliveroo vouchers, so whoever can tell me what is missing from the stuff we're demoing today when we go back to venue, I'll give you a Deliveroo voucher to get some lunch, dinner, or just get energized during the event. I might also just give them out. So we've got a long hack. So yeah, we'll probably just end up giving them out anyway. But yeah, if there's one today for anyone that can tell me that particular thing. Anyway, that was a side note. I know we're getting close to, well, we've got 4 minutes. We might go a slight bit over. So once those details are then passed on through this flow, this is called a flow jump. Actually, there's probably a better name for it, but I'm going with that name. And what this does, this actually jumps you straight to a reusable tab called, well, send it an SMS. And it's pretty similar to the other ones we've already looked at, except the last part of this, like it's still generating a token and whatnot. It's just using the details that we pass through to it to send SMS. And this is the same one used to respond back to incoming SMSs with environment. So you can see why we've kind of reused the existing demo and just kind of built on top of it. And that's the good thing about these demos is you can do all sorts of amazing things with it once you've got it up and running. So I'm going to quickly step through, where's my screen share gone? Oh, there it is. I'm going to switch over to the Arduino window. Switching window, there we go. I did have all this ready to go on OBS, just saying. We're being agile, that's fine. So let me make that a bit bigger. So what we've got in here, so we've got the MKR libraries in, we're using PubSub client. You could also use the Arduino PubSub library as well, will work just as fine. We've got the environmental shield loaded, the IMU shield loaded, and these devices generally don't know how to do pretty much everything you could normally do with a web browser or with a mobile device. So they need to know how to do JSON. This library is amazing for that. We'll step through that in a sec. My details are on there. So for my device to register, so I'm going to scroll that out a shot. You probably already saw them anyway, that's fine. And then, yeah, as you can see here, this is just all about formatting things. So setting up the org for the broker registration for the PubSub library, the topic subscription, or at least one of them, there's a couple of them, which I'm not storing in variables, probably should, but yeah, they're not because we're only using them one time. So didn't do that. And then these details here literally just for the What's an IoT broker connection. Not going to step through all these because they are literally just initiating libraries and things. This callback here is that part of that environmental shield registration of details. So you can see there it's grabbing humidity, pressure, luminance, UVI, etc. With this here, this is that response to a thing being asked. So when I walk through that bit where it's triggering the device to send all those environmental details, this is what it responds with. Yeah, that's basically it there. And then it's building it into a JSON string and then serializing it and then sending it back to the sensor part of the sensor topic back on the broker, just with a buffer and character count. That's a reconnect for the MKR side of things.
Can I jump in on the topic thing? Because I was pretty new to IoT brokers and stuff when we first went through this. So that loop that says if message is on. So that on is the name of the topic that we were subscribed. No. The topic we were subscribed to is
sensor.
And
sorry, that was trig. There it is.
Trig, that's what it is. So the topic we're subscribed to is trig. And so when a message that says on is sent to that topic, the device hears it and then it says, oh, okay, here's my environmental sensor readings.
Yes.
Okay, got it.
Yeah. And then it sends those back to the topic called sensor just to keep them separate because you can have as many of these as you want. It just sends it back into the sensor topic back on the broker. And Node-RED picks it up from there and sort of does a reverse and it says, oh, yeah, I know what to do with this. Reconnect is just a continual loop as part of the loop at the bottom that we'll get to, which we're not too far away from. Essentially, if the device has dropped its Cat1 connection for any reason, just reconnects. I think that was probably the easiest bit of this one. And then in the setup loop, so this is just initiating two different shield types. I was actually surprised when both shields worked, but they work fine. So there you go. I was more worried about power, but yeah, it seems to be fine. This is literally just start doing the usual serial start thing. Set it to 9600. You could set that to any value in the serial monster. Does the connection to, or hopefully does the connection to the Cat1. Let you know that it's connected, which is always handy because sometimes you don't know. Yeah, that's actually always a good sign that things are working. Sets up the server inside the pub sub library. So I've got the broker and port sitting there, and then sets the callback as well, which is where all the environmental shield magic happens. Then we get to the good bit. So yeah, we did go through a whole bunch of, actually, I think I've left, yeah, that there could actually come out. But anyway, nothing like live edits. Inside the loop, we're doing the reconnect connect thing. So if connection does drop, it's just going to reconnect again and then continue on through the loop. So this did take a few days to sort out, only because the math involved is quite full on. But this was the most refined version we got of it. And like Michelle said, it is far from perfect, but it kind of works, at least for purposes of this. You feel free, there's a whole bunch of libraries, feel free to, improve this. Actually, you could contribute back to our GitHub if you wanted to. But also what we're doing here is we're grabbing from the IMU shield, the accelerometer, we're grabbing the XYZ, also known as X1, Y1, and Z1, just to make it extra math-like. Doing a square root on all three at the same time, bringing back a nice flat number, and then that is kind of like a calibration number, because that calibrates the device for right now where it is not moving, and then versus that then gets compared to where it is moving at a great rate. And we've added a bit of a threshold there. Again, this is pretty high level. You could probably, there's a bunch of blog posts on making this a whole bunch more accurate and refined, but you get the idea. Is then it uses that to be able to determine that there's a variance that has occurred in the looping. The tricky part with working out XYZ inside an Arduino loop, that's so meta, is so the loop, those that are familiar with arrays and loops, etc. in programming, this loop runs at 1,000 milliseconds. Runs at 1,000 milliseconds. I don't know where I was going with that time-wise, but the thing I'm trying to say here is time is a big factor in this, because basically over a series of timed loops, you need to be able to determine the velocity at which the device is moving, and it could be X, Y, or Z, because you don't know which way is actually up from the device's point of view. So it's kind of time over loop time with X, Y, or Z. Yeah, anyway, the math did us in for a few days. There was many lightboarding sessions, but this works. This works all right. So essentially what we're doing here, working out the variance threshold over time, and then building a JSON string that just says fall is true, and it puts it back into the fall broker. And that's kind of it. Should we demo? We should demo.
Yeah, we should demo. Let's put our videos back on.
Okay.
And you might need to share the...
Oh, yeah, let me put my message.
I should just get shorter cords for this so that the battery is smaller. We had a couple of more questions in the chat. So Evgeny asked, I guess this doesn't have location services. So no, that just happens that the sensors we have here don't have GPS, but you could get a GPS sensor and connect it, and you can have location services too. And then Reno shared a cool little Arduino picture there with something that they've worked on. So I'd love to hear more about that. And then poor Chilu has their hand up, and I still can't see their thing in the chat, so we'll answer you later.
Hang on a sec, I'm going to share my whole screen. Live really dangerously.
Oh, gosh.
And then I've got messages turned off, so no one can message me. But the reason being, because the good thing about Node Red is you can actually see the data the requests coming in. So I thought that could be fun to show. Should be able to see my screen there. So if I send one of the trigger words, actually, I'm just going to send test. It's back to what can go wrong. Let's make sure my iPhone is unlocked. So if I send test in, you'll actually see the, hopefully see this. There we go. So, so in this flow here, which is the webhook registered with Telstra Dev. Oh, there we go. Devices also had a fall.
That was me, sorry.
That's all right. It's easy to know. So if I ask it for temp, it'll actually be able to run back then with temperature as well. There we go. Probably could have rounded that temperature down, but you get the idea. We like to be precise sometimes. And then also added in times in that as well. So time when it was those values were updated versus now, it's got a bit of JavaScript in there to be able to work that out and use that in response so you know when it was done. You can also see that message coming in as well. So you can see there, it will actually show the message that's coming from Telstra Dev through the endpoint, which is kind of fun as well. Really good for debugging this is.
Absolutely.
So the device alerts side of things, I'm going to open that up so we can see when a message is being sent out. There we go. So it's kind of good to go.
All right, let's see if this works. So I've got my Arduino here with my battery.
There it is.
And if I drop it, oh, something happened. Hey, that worked, didn't it?
There's two. Yeah, it got one and then it got another one. That's all right.
So the way that it works, if I move it really slowly, it probably shouldn't, but it just did then. Maybe unless you shook yours. And then if I drop it, it'll do it again. And, you know, like we were saying, we're finding the square root of X, Y, and Z. So it doesn't really know what direction it's going in. So if your device just goes left and right like that, or if it goes up, it's not necessarily just falling. It's more like we're measuring, is there significant acceleration on the device that exceeds our thresholds? So you could, like Developer Steve was showing in the sketch, you could take those thresholds for, you know, if the square root of X squared, Y squared, Z squared is above this number or below this number. You can just change those numbers and see what happens in your sketch. And Lachlan asked in the chat, where does the sketch live inside the node? And I think we got to the sketch last. So this Arduino sketch is not in the node red instance. The Arduino sketch is here and we deploy it straight onto the board. So this board, like when you connect it to the PC, the screen that Developer Steve's showing there, you just deploy that to your board, which will then store it onto the board. So now when I disconnect it, because I've got the Cat M1 network, it will keep running that sketch locally on the board, which is pretty cool. And sorry, you would have got so many texts from that because I was shaking the device around. But
just a few, but that's fine. You're paying for it.
Yeah, that's true. Thanks, Telstra. Oh, funny. There we go. We've got a couple of falls there. So it worked, which is great. And what else? There's no more questions coming up in the chat that I can see. I don't want to speak like too soon. Yeah, how are we going there, Developer Steve? Is it all working on your side too? It's all going good?
Yeah, we're good. Both demos worked, and yay for living dangerously. I'm going to switch my camera back on now.
Yeah, put your camera back on so we can see each other.
Hey, there we go.
And I think this is being recorded, which is great. So hopefully if we went a little bit too fast over some things, the first thing you can do is check out the GitHub where we have a very detailed README that should say exactly what we were talking about today. Hopefully we'll put this video up somewhere. And of course you can message Developer Steve and I at any time. Thank you, Laura. Laura just said she'll post the recording. You can message us at any time, even after the hackathon. So especially during the hackathon, if you want to use these tools within your prototype over the next couple of weekends, definitely. And if you want to take this from the hackathon and take it into the, something else, then we can. So Andrew has just asked, can everyone please turn on their cameras? So I think we probably want to take like a group photo or something. Andrew, are you able to go off mute and talk or? Yes.
Can you hear me?
Yep.
No, we can't.
No,
I'm joking.
Oh, look, people are coming in. This is great.
I'm going to change my scene because this event has been out of this world.
Hey, thank you so much for your questions. I think it's always really hard to do an event online, especially because, you can't see the people that you're talking to. You don't know if anyone's listening, if anyone's following, are we talking too much, not talking enough? I don't know if I've dropped out of the call. I couldn't even tell. But it's so good to see you guys posting questions in. I've really, really enjoyed it. So thank you again for participating. And I'll hand over to Laura and Andrew.
Yeah, I've taken the together mode picture, so there you go.
Oh, you've taken it. I was talking.
No, that's cool. You came up really well, Steve. You're a bit weird, but
oh really?
But yeah, no, sorry, no, you're good. It's all good. It's good. It's good. Okay, it looks good. I'll turn off together mode now. It's weird. Anyway, okay, cool. Thanks, guys. Yeah, awesome. The Developer Steve and Michelle Howie, thank you so much. It's been so wonderful. Everyone's loved it, and we've had a really good turnout too. So I think, yeah, well done, everyone. Be a big hand. Yay!
And I've just.
Oh wait, I have a scene for that. Thank you for being an amazing audience.
Yeah, we are pretty incredible, aren't we?
I've just put up that final slide. I don't know if you can see it or what this is. Okay, you've got Chewbacca there. Just with our details. So our websites, our Twitters, our company's Twitters, whatnot. So please connect with us even after. Yeah, and I would love to see if someone actually does this, does this demo and can do it back. So Laura has said, if you want to continue chatting, please head back across to Cloud Theatre. Maybe someone can post a link back to that in this chat so we can all join in there. So thank you again, everyone, as always.
Thank you all.
Bye.
Thank you.
Bye.
Thank you.
Welcome, welcome.
Hey, could you take a quick question?
Yeah, sure.
I've tried using